Imagine building a massive monument out of multi-ton stone blocks, but you are specifically forbidden from using glue, concrete, or any chemical adhesive. It sounds like an impossible constraint, yet across India, sprawling temple complexes were constructed following exactly this rule. And despite the total lack of mortar, many of these towering structures have stood perfectly vertically aligned for nearly 1,000 years. The enormous carved facades and heavy stone wheels remain seamlessly integrated, locked in place without a single drop of modern binder. Modern skyscrapers rely on reinforced concrete to resist sliding forces. These ancient builders achieved the same result through a network of mechanical interlocks hidden within the stone. The builders didn't simply stack raw rock on top of each other. They shaped the stones to act as their own mechanical fasteners. By carving protruding tongues and matching grooves, they created dry masonry joints that blocked the stones from sliding horizontally. They also cut precise dovetail connections. Because the trapezoidal shape flares outward, the neighboring stones naturally resist outward tension. Through this intricate carving, the heavy rock itself performed the exact same function as modern glue to hold everything together. But there is a secondary layer of engineering hidden inside the walls. Builders strategically carved out channels between adjoining blocks and dropped in iron and copper clamps. To stop the metal from rusting and restrict microscopic shifting, they poured molten lead directly over the connectors to seal them in place. You won't see these metal bindings from the outside. They were buried deep inside the masonry on purpose. The highly decorative exterior completely hides a strict, invisible grid of mechanical locks, forcing thousands of individual blocks to behave as one unified, unbreakable monolith. This explains the walls, but how do enormous stone roofs weighing thousands of tons remain suspended in the air for centuries without buckling? Modern architecture often treats gravity as an obstacle. These builders treated it as a primary binding agent. Through intelligent load transfer, the immense vertical weight of the upper canopy physically forces the interlocking joints below to squeeze even tighter. If you had to build a monument designed to survive for 1,000 years, would you choose modern concrete or carefully carved stone? Drop your choice in the comments below. While the massive weight provided compression, preventing the entire structure from shifting under that pressure required microscopic precision at the joints. The stone dressing is so meticulously executed that it is nearly impossible to slide even a thin blade between the resting blocks. Achieving this level of flawless alignment seems incredibly difficult without laser levels or CAD software or heavy mechanical cranes. Instead, they relied on a highly disciplined toolkit: plumb bobs, measuring cords, strict mathematical ratios, and endless repetition by skilled hands. They used precise geometric templates to guide their cuts, effectively turning mathematics into their software and heavy machinery. The marriage of applied geometry and immense gravitational pressure created a structural bond that required no chemical adhesives. The architects also anticipated environmental threats, engineering specific features to guarantee long-term durability. They carved dedicated drainage channels into the masonry to redirect water away from critical joints, and elevated the bases on raised platforms to prevent moisture rot from the ground up. Inside the walls, they mapped out balanced load paths, calculating exactly how the weight should distribute to drastically reduce stress concentrations on any single stone. Our building materials have clearly evolved over the centuries, but modern engineering still relies on these exact same principles of load distribution and interlocking connections. Their formula for survival was simple but incredibly demanding: precision cut masonry, interlocking joint physics, targeted metal reinforcements, and highly intelligent load design. The survival of these complexes demonstrates that long-term stability is a product of how individual parts are integrated, rather than the strength of the material alone. The next time you observe an ancient stone monument, look past the beautiful carvings, analyze the structural joints, and pay attention to how every single individual block depends on the ones around it. Could modern engineers recreate a massive structure that lasts a millennium without a single drop of cement? Let us know your thoughts. If you enjoyed this engineering mystery, please like this video, share it with a friend, and subscribe for more deep dives into history's hidden mechanics.